An apple falls from a tree. You know exactly why. You have known since childhood exactly why. Gravity pulls it down. Invisible force. Clean explanation. 300 years of successful predictions. Planets, moons, satellites, dropped keys. The model carries the name of the most famous scientist who ever lived. It is the first scientific explanation most people ever learn. Newton himself could never answer the one question the model left open. How does it reach across empty space? No contact, no medium, no mechanism. He wrote that he would feign no hypotheses about the cause. Those were his exact words. He had the equation. He had no explanation for what it was actually doing. In that admission, the first crack in the model was already there. Gravity is not a force. It is the shape of space, and you feel it every time you stand up. That sentence ends 300 years of certainty in one breath. In 1915, Einstein published the general theory of relativity. It was not a correction to Newton's equations. It was a replacement of the entire physical picture underneath them. Newton described what gravity does. Einstein described what gravity is. And what it is has no pulling force in it anywhere. The mechanism took Einstein 10 years to find. Space and time are not two separate things. They are dimensions of a single four-dimensional structure. Call it spacetime. The geometry of that structure determines how objects move through it. In the absence of mass, the geometry is flat. Objects travel in straight lines. When mass is present, it curbs the geometry around it. The Earth's mass curves the space-time in its vicinity. An apple on the tree is held in place by the branch. When the branch releases it, the apple does what any unforced object does. It follows the straightest possible path through the available geometry. That path, in Earth's curved space-time, points toward the center of the Earth. The apple was not pulled. It was released into geometry. The geometry does the rest. The apple never felt a thing. That path has a name, a geodesic, the straightest line possible through curved space. In flat space-time, a geodesic is a straight line in the ordinary sense. In curved space-time, a geodesic bends, not because something pushes, because the space it cuts through is not flat. Place two parallel lines at the equator of a globe, heading north. Both lines are perfectly straight, no curves, no bends. They converge and meet at the North Pole, not because something pulled them together, because the surface was curved. Two objects in free fall near a massive body converge for the same reason. They follow straight lines in curved space-time. The curvature brings them together, nothing else. Straight lines, curved space. That is the entire mechanism. The International Space Station is moving at roughly 7.7 kilometers per second. The common instinct is that it is being pulled toward Earth and kept in orbit by its forward speed. Two opposing forces, a stable circle. That picture is wrong in mechanism, correct in number. In the geometric picture, the station is not being pulled anywhere. It is following its own straight-line path through curved spacetime created by Earth's mass. The combination of the station's velocity and Earth's curvature produces a path that loops, an orbit. There is no force pulling it inward. There is no tendency pushing it outward. There is one unforced path through curved geometry, and the station is on it. The moment an engine fires, a real force acts. The station departs from that path. It must later return or establish a new one. Force is the departure from natural motion. Gravity is the natural motion. This is the inversion that Newton's model never made. This is not a refinement reserved for black holes and neutron stars. It is the physical reality operating around you right now. The proof is already in your pocket. Your phone locates you using signals from satellites orbiting at roughly 20,000 kilometers altitude. Those satellites carry atomic clocks. Being farther from Earth's mass, they experience slightly weaker space-time curvature than clocks on the ground. Weaker curvature means time runs fractionally faster. The difference amounts to roughly 45 microseconds per day. Without correcting for this, GPS receivers accumulate position errors of roughly 11 kilometers per day. The system would be useless within hours. Every GPS device on Earth runs on Einsteinian gravity. Every time your phone tells you where you are, it is using a correction that Newton's model cannot produce. Relativistic gravity is not an exotic edge case, it is infrastructure. Newton's model is a force acting on mass. Light has no mass. A force acting on mass has no grip on light. Newton's model therefore predicts that gravity cannot bend light at all. The geometric model predicts the opposite. Gravity is a curvature of spacetime. Light must travel through spacetime. Light must follow whatever geometry spacetime provides. Near a massive object, that geometry is curved. Light curves with it. The bending is not optional. There is no path through curved spacetime that stays straight. Eddington went to check. On May 29, 1919, Arthur Eddington was on the island of Principe off the coast of West Africa. A total solar eclipse was scheduled. The moon's shadow would block the sun long enough to photograph the stars near its edge. In ordinary daylight, those stars are invisible. During totality, they appear. Eddington measured the apparent positions of those stars and compared them to their known positions in the night sky. The stars had shifted. Their light had bent, passing close to the sun. The shift matched exactly what Einstein's curvature model predicted, not where Newton's force model placed them. The announcement came in November 1919 at a joint session of the Royal Society and the Royal Astronomical Society. Einstein became world famous the following morning. The geometric description of gravity had been directly confirmed. The force model had been ruled insufficient. That was over 100 years ago. The force model has a third failure. Newton recognized it himself. Newton's gravity acts instantaneously across any distance. Remove the sun from the solar system, in Newton's model, Earth immediately flies off in a straight line. The gravitational change propagates at infinite speed. Newton found this deeply uncomfortable. It required action at a distance through empty space with no mechanism, no delay, no explanation. He published the equations without resolving it. Einstein's model replaces instantaneous action with propagation. A change in mass or position sends ripples through the space-time fabric outward at the speed of light. Gravitational waves. On September 14, 2015, the LIGO detectors registered a shift in space-time geometry from the collision of two black holes 1.3 billion light-years away. The distortion reached Earth at the speed of light. Two laser arms, each 4 kilometers long, detected a shift in length smaller than 1,000th the diameter of a proton. The curvature model of gravity is not theoretical speculation. It is measured, recorded, filed. The most common pushback is this. If the geometric model and Newton give the same predictions in daily life, isn't the force model just a simpler but valid description? The answer is precise. They give the same numbers in weak gravitational fields, near moderate mass, at slow velocities where curvature is small. In those conditions, Newton's equations are a close approximation. But matching numbers in special cases is not the same as describing the same physical reality. Newton's model makes a specific claim. Gravity is a force transmitted between masses through some mechanism Newton could not identify. That claim is not a simplification of Einstein. It is a different and incorrect description of what is happening. A map that correctly shows every street in a city but places the city on the wrong continent is not a simplified map. It is wrong in a way that only becomes visible the moment you try to leave the city. Newton's model is the wrong continent. For dropping keys, it does not matter. For GPS, for light bending, for gravitational waves, for black holes, it fails. The numbers match, the universe does not. The problem runs deeper than prediction. When a physicist uses Newton's equations for an engineering calculation, they are using a shortcut that gives the right numbers. They are not claiming a force is propagating between the objects. The equation works. The physical picture it represents does not. That gap matters. The wrong picture produces wrong instincts the moment conditions move outside the narrow range where the shortcut holds. Students who learn gravity as a force find black holes paradoxical. How can any force be strong enough to trap light? Students who learn gravity as geometry find black holes straightforward. Of course, light cannot escape spacetime curvatures strong enough that even the outward path curves back. The wrong picture is not just wrong, it is a trap that makes the correct physics harder to reach. The weight in your body right now is inside that trap. You are sitting in a chair. The pressure beneath you feels like gravity pressing down. In Einstein's framework, the natural, unforced state of motion near a massive body is free fall. An object falling freely, no air resistance, no surface contact, no external forces, is following its straight-line path through curved space-time. It is in the most natural state available. It experiences no force at all. Astronauts in orbit are in free fall. They feel weightless. The shuttle does not cancel gravity. It falls continuously around the Earth. Its horizontal velocity keeps it moving forward fast enough that the Earth curves away beneath it at exactly the same rate it falls. The weightlessness is not the absence of gravity, it is the absence of any force resisting the fall. That is the natural state near Earth's mass. You are not in it. The Earth's curved spacetime is directing you towards its center along your straight-line path. The chair is in the way. The chair pushes upward, a contact force, real and measurable, preventing you from following that path. The force you feel right now is the chair. The sensation of weight is the result of being stopped from falling freely. Gravity is not pressing you into the seat. The seat is pressing you away from where the geometry of space-time would take you. Every floor you have stood on was the thing between you and free fall. Every chair, every bed, every surface you have ever touched was interrupting your natural path through curved space and calling the interruption gravity. Falling freely is the safest thing physics can offer. Standing still is the accelerated state. Falling is the natural state. The force you have felt every day of your life is not the experience of gravity. It is the experience of the surface beneath you resisting your fall through curved space-time. The moment you step off the edge, the force disappears. The stomach drop sensation of a cut elevator cable, that is not the sudden presence of gravity. That is the sudden absence of the thing that was stopping you. For that instant, you are in the state physics considers most natural. Nothing pushing back. Physics calls that weightlessness. Schools call it falling. The school curriculum is where the correction stops. Einstein settled the mechanism over a century ago. In most countries, the primary physics curriculum still introduces gravity as a force, not as a historical model, not as a useful approximation, as the explanation. Children learn Newton's pulling hand before they learn that Newton admitted having no idea how it worked. They learn the force model as settled science at the age when mental models are hardest to overwrite. The approximation is presented as the truth. The truth is left to university electives if it arrives at all. After this, the misconception becomes self-reinforcing. You would have to leave the framework entirely to find what it withheld. The physics did not hide. The correction had every opportunity to arrive. Experimental confirmation came in 1919. Gravitational wave detection came in 2015. At each of those moments, the textbooks could have been updated. They were not. The reason is not conspiracy, it is inertia. The force model works well enough for every problem on the exam. Every bridge, every rocket trajectory, every falling object, and every lab exercise, Newton gives the right answer. The wrong picture produces the right number. That is the exact condition under which no one demands a correction. The number passes, the picture stays. A century of settled physics sits in university libraries. The version that was superseded keeps appearing in the first lesson of every child's science education. That is not a small gap. That is the correction mechanism failing at the only scale that matters. Gravity slows time. This is not a metaphor. In curved spacetime, time passes at different rates depending on how deep in the curvature you sit. Closer to a massive object, spacetime curves more sharply and time runs slower. At Earth's surface, time runs fractionally slower than at the altitude of the GPS satellites. The effect is tiny, microseconds per day, but it is real, measurable, and it accumulates. Over months and years of GPS operation, the relativistic time correction is not a refinement. It is the difference between a working navigation system and one that tells you that you are 11 kilometers from where you actually stand. At extreme scales, near neutron stars, near black holes, the time dilation is not fractional, it is enormous. Time near the event horizon of a black hole runs so slowly that from outside, a falling object appears to halt at the boundary, edging closer, never crossing. The person falling experiences nothing unusual. The observer watching from a safe distance sees them suspended forever at the edge. This is not a thought experiment. Every observational test has confirmed it. The clock inside your phone already knows. Newton's equations will keep running in engineering contexts where relativistic corrections are smaller than the measurement error. They work. But the universe they describe, a mysterious force reaching across empty space, acting instantaneously, grabbing mass from a distance, does not exist. Einstein's universe is the one you are actually in. Mass bends the geometry of spacetime. Objects follow straight lines through that bent geometry. The sensation of weight is the surface pushing back against your natural fall through curved spacetime. Light curves around stars because there is no path through curved spacetime that stays straight. Newton gave the right answer. Einstein gave the right universe. The apple is still falling. It is not being pulled. It is following geometry. The difference between those two sentences is not philosophy. It is the difference between a description that works and one that is true. The Laser Interferometer Space Antenna, LISA, is scheduled for launch in the 2030s. It will detect gravitational waves from sources Newton's model cannot even name, merging supermassive black holes, the earliest moments of the universe, space-time itself oscillating across billions of light years. LISA will map the geometry of space-time at scales no ground-based instrument can reach. It will read the curvature of the universe directly. What it will not do is change a single classroom on Earth. The force model will still be the first explanation most children receive. The apple will still fall toward the ground in every textbook diagram. The pulling hand that Newton admitted did not exist will keep appearing in curricula, long after LISA has measured the fabric of space-time from orbit. The geometry will be confirmed again. The correction will not arrive.